So this morning I'm just showing a 60 kilowatt array we installed a few years ago up on the childcare centre. And I just thought I'd run through a few of the features with you. So you'll notice that each string is in a group of 12 panels each side, and then obviously a string cable runs up to from down below where the inverters are, which I'll take you down there shortly. Each string comes up into a isolator, a DC isolator. Now DC isolator is not actually required anymore, but at this time it was. So the DC isolators are enclosed under a cover like so, and then all the string cables actually run up in these metal ducts on one side and metal duct on the other. Now the neat thing about doing it like that is that we get quite a lot of mechanical protection, basically UV protection of the conduits, because all the string cables are still in conduits in this ducting, but you know, it's very helpful to have good mechanical protection. So you'll see here, there's the conduit there coming out of the duct, and then it comes around, it comes into the DC isolator, and out of the DC isolator it goes into the array. So it's quite a neat, tidy way to do it, and it's quite a good way to do it for longevity. We've also spaced the array so that there's plenty of room around it for maintenance. Now, not every roof is ideal for solar. So for example, it's always better obviously to get the solar panels at 30 degrees facing true north, but it's not always possible. And when you can't achieve that, you do have some system losses. And the way to overcome those system losses is basically to increase the size of the solar array. So if you've calculated that you've lost 10%, well, you might oversize the array by 10%. So that you're still providing the output that the customer needs. Another thing too, when you get solar panels that are flat, well, these aren't quite flat, they're probably at about 4 or 5 degrees, is that they do need to be cleaned more often, because you do get a little bit of moisture build-up here. So for that reason, we also got the builder to make sure that the plumber installed a tap up here on the roof, so that it was easy for the maintenance guy to come up, hook up a hose and just brush them down. And I think they're just in the habit of cleaning them now, you know, every 8 or 9 months or so. Another thing about solar panels is it's if you can keep them cool, they work better because they have what's called a negative temperature coefficient. So keeping them up off the deck, like so, to let some air coming in under them, and obviously keeping the groups, the strings spaced apart, the array strings placed apart, you're also going to achieve some level of cooling. So all the string cables come up, come around in the ducting all the way. Same on this side. All the conduits are in the ducting all the way around. In fact, I'll just show you inside the ducting. You can see here inside the ducting, so there's all the conduits there. Okay, so the cables are still actually inside the conduit. It's quite a tidy way to do it. So, all the string cables, they leave the roof, they come down into the plant room. So they end up out of this coloured duct into a cable ladder. The cable ladder goes down through the building, goes down across the plant room, down into the area where the inverters are located. So this is what we call the inverter stack. You'll see that there's 60 kilowatts of inverter, so we've got 20 kilowatts, 20 kilowatts, 20 kilowatts. Now this box here that you can see, that's called a network protection device. And each inverter is connected into that network protection device. And the whole idea of that device is that it actually operates very similar to an individual inverter. It's measuring voltage and frequency. And what it does is if there was a line disturbance or a disturbance on the local grid, it actually trips out all of the inverters simultaneously, which is very useful. If we open up the cover here, you'll see here we've got, that's the mains coming in down from the main switchboard down below. It goes through this contactor here, and then the cables come out of there and they drop down onto this bus bar here. And then I've got inverter 1, inverter 2, and inverter 3. And this is all this up here, this is the line sensing equipment. So this is sensing frequency, voltage, so that if it goes outside certain parameters as dictated by Australian standards, then this relay over here will trip out, which basically switches off all the inverters. The string cables, as I saw before, they come down these ducts here, but you'll notice here that we've had to use string fusing, because in some cases more than 2 strings are parallel together, and what that does is increases the current beyond the reverse current of the solar panels. You'll probably learn about that in class, I imagine. So the string from the top comes down, it comes across the fuse, out of the fuse, and then will come up into an inverter. So at the moment it's early morning, but we're producing 6.8 kilowatts. So this system's been very useful here at the site. It's saving the site around about $18,000 per year, which basically means the system will pay for itself within a 4-year turnaround. So that's a fairly typical 60 kilowatt solar array installed on a building, basically offsetting all the daily load requirements. And at a place like a child care centre, most of their electrical load is in the daytime, and most of it's centred around air conditioning units and hot water. So solar in this case is very, very effective and provides a very good return on investment. And that's it.